So again, those of you that just showed up, happy Wednesday, happy hump day, happy middle of the week. So again, all we're doing here is we're learning three things: sine, cosine, and tangent. And each of those are ratios. That's it, is a fraction of two of the sides of your triangle. When I say sine, when I want to find the sine of an angle, that means I want to make the ratio of the opposite leg over the hypotenuse, like we just did in the warm-up. When I talk about cosine, and somebody's saying, Mister, what do you mean by opposite? Opposite means the other side. So whatever angle you're standing at, it's the leg that's in the other side. So opposite leg. For cosine, I want the adjacent leg over the hypotenuse. And adjacent may be a new word for you. It means next to. It means next to. So I want the leg that's next to the angle. Right? You'll never see just cosine by itself. You're going to see or sine by itself or tangent by itself. Right? Tangent for short, tan for short. You'll see an angle measure or an angle next to it because you need to know where you're standing. Right? I can't just say, "Oh, guys, find the sine of this." Find the sine of what? You need to tell me an angle, mister. Oh, sine of A. Oh, okay. That's the opposite. That's the hypotenuse. You have to know what angle. So you'll never see sine, cosine, and tangent by itself. You'll see an angle next to it. So sine is opposite leg over hypotenuse. That's how we make our ratio. Cosine is the adjacent leg, which means next to, over the hypotenuse. And tangent, does anyone know what tangent is? What's the ratio of tangent? What are the two things we're looking at for tangent? If you don't know, it's okay. I'm just wondering if anyone does know. Nobody knows? Okay, that's fine. I just thought someone might take a guess. Tangent is very useful because sometimes the hypotenuse is hard to measure. In real life, sometimes that hypotenuse is hard to get. And sometimes you can only get one leg and one angle. And that's fine. So tangent is opposite leg over adjacent leg. So it has nothing to do with the hypotenuse. It kind of ignores the hypotenuse. So that's what tangent is. Okay, so sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Now, you do not have to memorize these. Remember I told you, every time we learn something new, there's always something at the beginning of your notes that you should know. And this is the thing you should highlight. Right? This is the thing you should highlight that you can come back to. And you always are welcome to come back to this and look at this. Put little stars around it. Right? This is the thing you're going to come back to. If you're like, wait, mister, I forgot what sine is. I forgot what cosine is. I forgot what tangent is. Come back to here. Or if you want to do it by memory, if you want to remember them, somebody a long time ago said, you know what? I'm gonna look at the first letters of all these things, and I'm gonna make a fake silly word. What happened? There we go. I'm gonna make a fake silly word, and I'm gonna make a silly word that says SOHCAHTOA. SOHCAHTOA kind of sounds like a word from another language, right? SOHCAHTOA. Why do we say SOHCAHTOA? SOHCAHTOA. Well, look at the first letters. S stands for sine. And then we have O and H, which means opposite leg over hypotenuse. Why do we say CAH? C-A-H, CAH. Well, C is for cosine. A is for adjacent leg. And H is for hypotenuse. And then TOA, T-O-A, the T stands for tangent. The O stands for opposite leg. And the A stands for adjacent leg. Okay, so somebody told me last period, Mister, keep it there. I'm going to take a picture of this. Okay, that's fine. But that's SOHCAHTOA. It just gives you a little way to remember. Sine is opposite over hypotenuse. cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. SOHCAHTOA. Okay, mister, you still haven't told me how these are useful. I'm getting there. I'm getting there. The first thing you need to know is what they are. Okay, and when I say sine, I'm talking about opposite leg over hypotenuse. That's just a fraction I'm making, a ratio. When I'm saying cosine, you need to know it's adjacent over hypotenuse. And when I say tangent, you need to know it's opposite over adjacent. Okay, so before I can show you how they're useful, you need to know what they are. They're just ratios. You just need to know what side to put what over what side. And SOHCAHTOA can help you remember that if you don't want to look at this chart up here. But this chart should tell you opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Okay, so now that we know what they are, and if we look here, we did this in the warm-up, right? We figured out this was 15 because that's 9 and 12. We wanted to find what the sine of W was. Well, that means you stay at W, and sine means opposite over hypotenuse. So opposite over hypotenuse. So that's why it's 12 over 15. And then you simplify. So if we look over here, sine of W is 12 over 15 or 4/5. Okay, if I wanted to finish this, chart right here, if I wanted to finish this chart and I wanted to do cosine and tangent, let's do that. Let's do that. Let me erase all this mess. Okay. So we know, again, that these are the legs. This is the hypotenuse, and we figured out what the hypotenuse was. We figured out that this was 15. And so now if I want to find the cosine of W, that means I'm here at W. And the cosine is what? Cosine, if you're in your head, you should say, oh yeah, cosine is C-A-H. Oh yeah, adjacent over hypotenuse. So here's my fraction bar. What's the adjacent side? So if I'm standing right here, if I'm at W, because that's what I'm finding, the cosine of W. If I'm here at W, the adjacent leg is this one. This is the other leg that's adjacent. Not this one. You're going to say, mister, isn't the 15 next to it too? Yeah, but that's not a leg. We need to find the adjacent leg. That's the hypotenuse. So there's only two choices for legs, that one and that one. It's not that one because that's a cross. It's this one, so 9. So we put 9 up here. And then what's the hypotenuse? The hypotenuse is only one, is 15. And if I want to simplify 9 over 15, I can divide by 3, and I get 3/5. Okay. And then the last one, how do I find the tangent? The tangent of W? Well, again, here I am at W. And what's tangent? In your head, you should be saying, oh yeah, tangent is opposite over adjacent. TOA, O-A, opposite over adjacent. Okay, so here's my fraction bar. So what's the opposite side? So if I'm at W, what's the opposite side? 12. So I put that on the top. And then what's the adjacent side? 9. So I put the 9 here. So tangent of W is 12 over 9, which is perfect, but I need to simplify. So if I divide both by 3, I get 4/3. That's how you find the sine, cosine, and tangent of an angle. I'll give you a minute to copy this down and to ask me any questions, any clarifying questions, because I want you to make sure this is all we're doing here, because you're saying, mister, we're not solving anything. No, this is not solving anything. This problem right here is not solving anything. We are just finding the ratio, because I want you to practice being able to find the ratio. Okay, then we're going to use this to figure out, to solve some stuff. But right now, we're not solving anything. I just want to make sure you understand how to find them, how to find the sine, how to find the cosine, how to find the tangent. Because if you don't know how to find it, you won't be able to set anything up and you won't be able to solve anything. So I'll give you a minute to do this, to copy this and understand this. And then we're going to find the sine, cosine, and tangent of x on this same triangle and see if you can do that. Okay, so let's do this. Copy that for a minute, make sure, and ask me any questions you have. All right, time is up. So now, some of you are asking, Mister, what if I'm not at angle W? What if I'm over here at angle X? Okay, so then that means I'm going to find the sine, cosine, and tangent of angle X. Okay, so how do we do that? What if I'm standing here at X? So sine, cosine, and tangent always depends on what angle you're talking about. That's where we're finding the sine of X or the sine of W, right? So if I was at X, what's the sine of X? So sine means opposite over hypotenuse. So now the sine, now that I'm over here, I'm not talking about this angle anymore. Now I'm over here at X. Opposite hypotenuse is 9 over 15. Or if I simplify that, it's 3/5. Okay. Cosine of X. So if I'm at X, cosine says adjacent over hypotenuse. So adjacent is 12, hypotenuse is 15. So my cosine of X is 12 over 15, which if I simplify it, if I divide by 3, I will get 4 over 5. Okay, so now we're finding sine, cosine, and tangent, but now our angle of focus or angle of focus is on X. Now it's the sine of X, cosine of X, tangent of X. Now I'm focused on here. So now when I say opposite, I'm talking about opposite of here. When I talk about adjacent, I'm talking about adjacent from here. Okay, so it kind of switches. It's different from W because I'm not talking about over here anymore. It's all about where you are. These trig ratios are all about if I'm at W. These trig ratios if I'm talking about this angle, angle X. And so the tangent of angle X, well, let's look at angle X. Here's X. Opposite is 9. Adjacent is 12. So this would be 9 over 12, which is 3/4. Okay. This is just writing down the ratios. You didn't solve anything. We didn't calculate anything. We just found the ratios. Now we're going to use this being able to find ratios to find side lengths. And I'll show you how in a second. I'll just let you copy this down. I'll give you a minute to copy this down. And then I'll show you how do we use these to find unknown sides in real, and then how do we use this in real life? That's how we use it in real life. If you look around you, everywhere in life, you can make a right triangle just about anywhere, right? If I want to find the height of anything, I can make a right triangle and calculate it. So let me give you a few seconds to copy this down. Then we'll do a problem, and I'll show you how this helps you. Okay, so now let's go down to, remember, we looked at this the other day, right? This is, now we're finding, so here we go. So now we're going to find side lengths using trig, okay? And we kind of looked at this, and I know it's just a regular triangle, but I drew a tree, right? I drew a tree, and I know my tree's not very good. Right, so here's my tree. I don't know. There's my tree. So I want to find the height of a tree. Okay, so imagine that this is the ground. This is the ground. This is me standing here. My eyesight, my line of sight from the ground all the way up to the top of the tree, it forms a 28-degree angle. And then straight down, that's a right angle. And then from the bottom of the tree to me, there's a distance. Okay, there's my right triangle. So imagine that. So I know it was just a regular triangle like this, but you know, if you use your imagination, you can see, okay, I'm going to try to find the height of this tree. So how do I do this? How do I do this using sine, cosine, or tangent? Well, the first question you have to ask yourself is, which one am I going to use? Right? Do I use sine, do I use cosine, or do I use tangent? And you cannot just use any of them. You have to use a particular one depending on the problem. Sometimes you might have choices, but for this problem, I really don't have a choice. If you look here, I'm standing here, right? So that's my angle. This is the angle that I'm at. Oh my gosh. What's going on? This is the angle that I'm at right here, this angle. So this is the angle I'm interested in. So now, what are the two sides of this triangle that I'm interested in? Well, I'm interested in this side right here because that's the height of the tree. That's where my x is. That's my unknown. So I need this one. And they give me the hypotenuse, right? They give me the length of the hypotenuse. They don't tell me anything about this side, and I don't care about that side. So if you look at the angle that I have to find the opposite side, and they give me the hypotenuse. So which one of these three deals with opposite leg and hypotenuse? Right? Because that's what the problem is dealing with. It's dealing with the opposite leg, and it's dealing with the hypotenuse. Which one of these deals with opposite and hypotenuse? Sine, cosine, or tangent? Sine. Very good, because sine is opposite over hypotenuse, right? And that's exactly what I have. I have the opposite, which I need to find, and I have the hypotenuse. So that's what I'm going to use. So these ones I'm not going to use. So I'm going to use sine. So I'm going to find, that's set up our equation. That's set up what we've been doing. So the sine of what? Well, the sine of this angle, right? Well, what is this angle? It's 28 degrees. So I'm going to say the sine of 28 degrees equals, okay, well, what's the opposite side from this 28 degrees? The opposite is x over, what's the hypotenuse? 19. So there we go. Just like we did up here, we set up sine of my angle equals opposite side over hypotenuse. So the sine of 28 degrees, we actually have a degree for this angle. The sine of 28 degrees is the opposite, which is x, over the hypotenuse, which is 19. And now that I have this, now that I actually have an angle measure here, now I can actually solve this and figure out what that height of that tree is. How do I do that? Just solve. Let me show you how. So the first thing I'm going to do is I want to get x by itself, right? I want to get x by itself. So I'm dividing by 19. I'm dividing x by 19. So what's the opposite of dividing by 19? What's the opposite of dividing by 19? Maybe I said that too fast. What is the opposite of dividing by 19? Because remember, when you solve equations, you need to do the opposite to get rid of things. And if I want to get the x by itself, I got to get rid of this. So I want to get rid of dividing by 19. You guys know a fraction means division, right? This is the division sign. Fraction means division. So what's the opposite of dividing by 19, guys? Hello? No one's answering me. What's the opposite of dividing by 19? What's the opposite of division, guys? Hello, is anyone there? Hello, am I talking to echo? Echo. There you go. Thank you. Multiplication. Thank you. So the opposite of dividing by 19 is multiplying by 19. So I'm going to multiply this side by 19, and I'm going to multiply this side by 19. So these cancel, and I get x equals 19 times the sine of 28 degrees. Guess what you can do? You can put that into your handy dandy calculator. Okay? Those of you that don't know that, you can go to your calculator, and I know most of you use your phone as your calculator, so you can go to your calculator on your phone and you turn it sideways. And sometimes this is just like the square root. Sometimes you have to put the number and then hit sine. So put 28 and then hit sine. and that'll give you the sine of 28, and then multiply that by 19. Some calculators you have to put sine first and then the degrees. The other one you put the degrees and then you hit sine and it'll find it. Please play around with your calculator. And so what do you get? We get x equals what? Right? Punch this into your calculator. And I want all of you to try it because all calculators are different. There are different calculators that do it different ways. So I'd like you to punch this in first. Always do the sine first. Put this into your calculator first and get a number. And then hit multiply or times 19. And tell me what you get. I would like all of you to try this. That way you know how to do your calculator with sine, cosine, and tangent. So please put this into your calculator first. Right? Punch this into your calculator first, and then whatever you get, put times 19, and then you'll get an answer. And what answer did you get? And you're going to get a lot of decimals. Just give me the first ones. Yes, 8.9. 8.9. If you got something else, be careful. Some of your calculators, you're going to have to make sure that your calculator, right, here's your calculator. Sometimes your calculator will have something in the corner that says deg or rad, right? Make sure that your calculator is in deg. That means degrees. Okay. If it's in rad, make sure you're out of that. That means radians. That doesn't mean, oh, rad. It means radians, which you don't want to be in radians. You want to make sure your calculator is in, it might have a little D or a little R right there. Make sure it's in D or DEG degrees. And yes, 8.9. And that's how we use trig to find out side lengths. Now, if we were in class live, if there was no pandemic, we would build a little clinometer and go outside, and together we would find the lengths of stuff. We would do this together. If you have me for Algebra 2, we will be doing this again next year when we go deeper into trig, and you will be going around with your little clinometers, finding the heights of things. So hopefully we can do that next year. All right, any questions? Any questions here? So, mister, how did you know to use sine? How come you didn't use cosine or tangent? Because the problem led me to it. You need to look at the picture you're given and see which one of these three it leads you to. How do you know? Well, here's the angle that I'm dealing with. And the side I want to find is the opposite leg. And this other side that they give me is the hypotenuse. So I got to ask myself, which one of these three has opposite leg and hypotenuse? And that was sine. And so that's why I used sine, because we were using the opposite leg and the hypotenuse. Okay, I'll give you a minute to copy this down. And then we'll do one more problem and we'll be out of here. And we'll do some practice tomorrow. We're going to do some classwork where you practice together tomorrow, finding the heights or lengths of things using sine, cosine, or tangent. But I'll give you a minute to copy this. And ask me any questions, please. If you're lost, if you're not paying attention, oh boy, you're going to be so lost. If you are a little confused and you're not asking questions, oh boy, we only have 7 more weeks of class, guys. Only 7 more weeks. So I'm just letting you know, if you're not asking questions as we go, you're not going to do too well, because this is all brand new stuff. You've never done sine, cosine, or tangent in any of your math classes before. So you should ask questions if you're confused. Okay, let's look at this other problem, okay? So we have a triangle. So the first thing you should always do is identify, okay, these are my legs This is my hypotenuse. You should always identify that. That way you don't get confused. Because remember, when I say opposite or adjacent, I'm talking about legs only. Okay, so that's a leg. And that's a leg. And this is the hypotenuse. Okay. And so now, what do we have? We have this angle, this side, and this side. So now we have to ask ourselves, are we going to use sine? Are we going to use sine, cosine, or tangent for this problem? Well, let's look. We have this angle, and then we have that leg, which is the opposite leg, and we have that leg, which is the adjacent leg. So which one of these deals with opposite and adjacent? Which one of these three deals with opposite and adjacent? Again, first thing you got to understand, those are the legs. That's a hypotenuse. Then you look at what they give you. They give you this angle. This is the leg you need to find. And this is the leg they give you. They don't give you the hypotenuse. So which one of these three deals with opposite leg and adjacent leg? Tangent. Very good. Yay, tangent. So we're going to deal with tangent. So we're not going to deal with those. We're going to deal with tangent because tangent is opposite over adjacent. So now let's set this up. So the tangent of the angle, what angle are we talking about? We're talking about this angle. The tangent of 41 degrees equals opposite. So what's the opposite side over here? X. So it's X over adjacent. Adjacent. Which one's the adjacent side? That the adjacent leg? It's this one right here. So that's 32. And so now to solve this, now I have my equation set. To solve this, again, I want x by itself. So what's the opposite of dividing by 32? Multiply by 32. Thank you, student. Multiply by 32. But you got to do it to both sides. So these cancel, and I get x equals. And now to get my answer, I got to punch this into my calculator. So do this first, do the trig first. What's tangent of 41? Plug that into your calculator. And then once you find that, multiply 32 to it to get your answer. And what do you get? If you're not doing this on your calculator, you're going to kick yourself later. How do you do this? I can't find it. How do you do sine? Where is it in my calculator? That's why I want you to try it right now. I'm doing all the work for you. All you got to do is put this into your calculator I just want to make sure you can put this into your calculator. You know how to do it. I want you to do this part first. And different calculators do it different ways. Sometimes you have to put 41 and then hit the tangent button. Sometimes you have to hit the tangent button and then put 41 and hit enter. It's different calculators do it different ways. But once you find the tangent of 41, multiply it to 32, and you should get 27.8. Okay? Any questions? Any questions? Okay, so we're going to practice this a little more. Yes, we didn't do the lesson yesterday, so I changed the due date for the homework. I put the homework due date tomorrow. So what I want you to do is I want you to start. You can start the homework tonight. You don't have to finish it. It's due tomorrow. Tomorrow we'll do a little more practice. We'll do some classwork so you can practice together in breakout rooms. Understand how to do this and set up the problems. But again, like we did first we need to know how to set up the problems like this. And then once we know how to set up, then we can solve problems like this. Okay, so if you don't have any questions right now, but if you think of them later, you can send them to me in Schoology, and I will for sure answer you as soon as I can. Right? You guys send me messages, and I try to answer as soon as I can. Sometimes I answer hours later, and I apologize for that. But if you have any questions, I will answer. I do look every once in a while. But if you have no questions, have a great day. Take care, and I'll see you tomorrow. Miss Rivas, thank you for your help. You too. See you tomorrow. Take care, everybody.